Hi, welcome to Precalculus. Today's topic is the Moivre's theorem with answers in standard form. What this means is that we have complex number in standard form, a plus bi. We want to raise it to power of n. We of course have two choices. One, we can use the binomial theorem and raise it to power of n that way. However, this could take quite a long time. We want to create a shortcut, and the shortcut is through de Moivre's theorem. De Moivre's theorem said if you have r, if z is r times cosine of theta plus I sine of theta, then z to power of n is simply r to power of n times cosine of n theta plus I sine of n theta. So when we are faced with a question like this, first we convert it to the polar form. From the polar form we find out what the nth power is, and from that we go and calculate these two, sine and cosine, and find the standard form. So we are taking a detour. Instead of going straight and calculating the power of some complex number, we first find the polar form, apply this theorem, and go back to standard. Let's see how does that work in this case. So our z is given to us as radical 3 plus I. That's what this is. We want to figure out what is z to power of 8. First we take this thing and write it as r times cosine of theta plus I sine theta. How do we do that? You remember that r squared, so if this is z is equal to a plus b times I, r squared was a squared plus b squared. And tangent of theta was also equal to b over a. This is from a lecture we had a couple of days ago. So in our problem, r squared is radical 3. This is radical 3, that's a, b is 1. I take each of them, square them, add them up. 3 plus 1 becomes 4, and r becomes 2. Tangent of theta is b over a. b is 1, a is radical 3. Another way to express this thing is radical 3 over 3. And our angle is in the first quadrant. We might as well draw this thing. We are at radical 3 and 1. So this is radical 3 and this is 1. This is the picture we have. We are at radical 3 plus 1i. Theta obviously is in the first quadrant, and it is pi 6. That's the value of theta. So I can write z. Z is twice cosine of pi 6 plus I sine of pi 6. We might as well verify to make sure we are on the right track. This is radical 3 over 2 times 2, radical 3. This is 1/2 times 2, that is 1, so we are right. Now, if I want to figure out what is z to power of 8, that's going to be 2 to the power of 8. And as we said in the previous lecture, we just multiply each of these angles by 8. Cosine of 8 pi 6 plus I sine of 8 pi 6. Okay, 2 to the power of 8, that is 256. We might simplify this thing so that it's a little bit easier to digest. 4 pi third plus I sine of 4 pi third. Now what is 4 pi third? We can go look it up in our table, or say, well, that's pi plus pi third. So that is pi third here. Pi plus pi third, that's what 4 pi third is. What is the cosine of it? 256 times cosine of 4 pi third, that is minus 1/2. How about this one? I times sine of it is minus radical 3 over 2. Multiplying, I get minus 128, and this one also becomes minus I times 128 radical 3. So all this work told us that if I take radical 3 plus I, raise it to power of 8, I get minus 128 minus I times 128 radical 3. Okay, let's go through this process one more time. We write our base, convert it to polar using this polar conversion formula. Raising it to power of 8 means the modulus raises to power of 8 and angles multiply by 8. Then you have to go back and convert this thing back to exact answers and write it. All the examples you see in this section, the angles are famous angles, and therefore you don't need to do any approximation. Let's do another one. This is z is equal to 2 minus 2i. We want to figure out what is z cubed. Now, cubing is not that bad. We can actually sit down and do this thing by hand, meaning multiply this thing by itself 3 times. Perhaps we come back and do it as an exercise. But first, let's do it this way. It says apply this theorem as opposed to just multiply. So r times cosine of theta plus I sine theta. Step 1 is to figure out what r is. R, sum of squares of these two numbers. So 2 squared plus 2 squared. So that gives me 8. So r is going to be square root of 8, or if you wish, 2 square root of 2. Tangent of theta, b over a minus 2 over 2. That's minus 1. Let's draw a little picture here. We have 2 minus 2. 2 minus 2 means I am at this location. So tangent of theta, you can say the angle is minus pi over 4 or 7 pi over 4, whichever you wish. You have both choices available to you. Excuse me. So before we want to calculate r cube, we want to figure out that this is 2 radical 2 times cosine of again, it's your choice. Previously the software was insisting that the angle be between 0 and 2 pi. Let's go with that. It's just as legitimate to use this, and the numbers are going to be a bit smaller for us. So that is z. Now what is z cube? I have to cube this. So that's going to be 2 radical 2 cubed, and then cosine of 3 times 7 is 21 pi over 4, and this is going to be I sine of 21 pi over 4. Let's clean this up a bit. 2 radical 2 cubed. What is that? Well, 2 cubed is 8. Radical 2 cubed is radical 2, radical 2, radical 2. Okay, so 2 cubed is 8. Radical 2 is just 2. So this becomes 16 radical 2. So I have 16 radical 2. 21 pi over 4. 21 pi over 4. That is so we are going to make our angles more reasonable. It's perfectly okay to just leave it as 21 pi over 4 if that's where you want to stop. That is perfectly fine. But we want to get a sense of where this thing is. 21 pi over 4, I separate 4 pi out of it. So this becomes 16 pi. I'm left with 5 pi. So 4 pi means going around the circle twice. That doesn't change the sine or cosine. So instead of 21 pi over 4, I can write the coterminal angle of it, which is 5 pi over 4. And then again, I sine of 5 pi over 4. Now, I can continue. Cosine of 5 pi over 4 is minus radical 2 over 2. And this is also radical 2 over 2. Multiplying through, I get radical 2 times radical 2 divided by 2. That all cancels out. Same way here. So I get 16 times minus 1 minus I, or minus 16 minus 16i. Okay, we said at the beginning that this exponent is small enough for us to try to do just algebra, which is if I have 2 minus 2i and I want to cube it, well, what do? Well, I square it and then multiply by itself. So it's perfectly okay to do it like this. Now 2 squared is 4, 2i squared is minus 4, twice the first times the second is minus 8i. So when I square this, that's what I get, times 2 minus 2i. Well, of course, these 4's cancel. Minus 8i times 2 is minus 16i, minus 8i times minus 2i. Product of minus 8 minus 2 is 16. I squared is minus 1, so I get minus 16. So that's what we got over there. You might be wondering, well, why didn't we do that from beginning? If the power is small, yes. If the power was large, this amount of algebra could go on forever and would not be all that easy to carry out. So that's why we use this theorem. One final example. I have, z is minus 1 minus radical 3. We want to find out what is z to power of 4. Minus radical 3i, of course. Well, where is this sitting? Minus 1 is here. Radical 3 is here. So that's our z. Z is looking at this location. If we find the z in terms of r and theta, we are all set. Okay, if this is 1 and radical 3, what's the radius? We have done this problem multiple times. You know that is 2. So z is equal to 2. What's our angle coming all the way here? That's going to be pi plus pi third. So I leave the steps to you, but here is a graphical way of doing this problem. We figure out where the z is. Z is 2 units out at the angle of 4 pi third. How did I get 4 pi third? Because this, in this triangle, that angle is obviously pi third plus pi makes 4 pi third. So z to power of 4 will be 2 to power of 4. Multiply your angles by 4, so 16 pi third. And I sine of 16 pi third. Now what is 16 pi third? 16 pi third we separate multiple of 2 pi, like for example we separate 4 pi here, and then I'm going to be left 12 out of that, that's 4 pi third. Okay, to make the problem manageable between 0 and 2 pi, we separate 2 pi, 4 pi, 6 pi, or whatever it takes, and until whatever angle is left is between 0 and 2 pi. Now that's going to be in our table. 2 to the power of 16 is 2 to the power of 4 is 16. Then cosine of 4 pi third plus I sine of 4 pi third. So that's going to be 16 pi plus pi third. That's going to be minus 1/2, and this is going to be minus, what was right? Minus radical 3 over 2 I. Multiplying through minus 8 radical 3. This one, again, power being 4, it's not bad to try to do it by hand, and you should get the same answer. Okay, so what was the idea here? Powers of a complex number can be obtained by the Moivre's theorem if you convert it to polar, apply his theorem, and then go back to the standard, and that will complete the problem. Okay, so I guess that we are done for today. Until next time, good luck and God bless.